What's up? What's up, guys? क्या हाल चाल? This is your captain. I'm back here. What's happening? I hope everyone can see me, everyone can hear me. Please let me know in the chat box what's up. All right. What's up, boys and girls? क्या हाल चाल? How are you? Thank you for showing up. Yes. Let me just find a place for the phone. Yeah, I just did. Hi guys, what's up? This is your captain Harsh Maheshwari. I am back to teach you guys, and today we have something very special called as SN2 reaction. I think you know that, right? So what's up? Let me know. What's up? Yes, bacha. All right, amazing. All right. So, have you guys revised SN1 reaction? If you haven't, do check that out also. Okay? And yes, I'm from NIT Warangal. I do believe in one thing, that jo karo, maze se karo. So today we are going to start SN2 reaction. Okay? And we are going to understand everything in detail. Okay? So without wasting any time, let's continue the session. Let's continue. Please, yes, subscribe to our channel and also hit the bell icon so you will be notified when I'm coming live. So you can watch my live lectures and always learn something new. All right, so let's start. ठीक है बेटा. Alkyl halide. SN2 reactions of alkyl halide we are starting. Let's study. All right, boys and girls. ठीक है. बच्चों, I'm pretty sure everyone is aware what is an alkyl halide. Let me just draw a beautiful alkyl halide for you. A beautiful alkyl halide for you. This X is your leaving group or this is nothing but your alkyl halide, RX. सबको समझ आता है? Everyone is understanding? Everyone is understanding RX, this is your alkyl halide. Alright, so this is your alkyl halide. Now what happens here beta in SN2 reaction? Let us understand. देखो, SN2 reaction, it happens in only one step. That is kind of ironical. This reaction will be over within one step. SN stands for nucleophilic substitution reaction, which is having the order 2. So bimolecular nucleophilic substitution reaction. Okay? So what is SN2? Bimolecular nucleophilic substitution reaction. And what is the most important part? It happens in how many steps? One step. This reaction is done and dusted in one step. Okay? Kind of ironical and easy to remember. SN2 reaction means it will be over in one step. Point number 1. What is the name? Nucleophilic substitution reaction bimolecular. Let us understand what does it mean in detail. So I am taking my substrate as alkyl halide. Point number 1, what I have taken? मैंने यहाँ पर alkyl halide ले लिया. ठीक है? Now beta, what happens? Nucleophile will come. What happens here? Nucleophile will come and it will attack this particular carbon, you know, there is a partial positive charge because of this alkyl halide. This halogen is inducing some polarity on the carbon. Carbon is having partial positive charge on it. So nucleophile attacks from the backside where the leaving group is not there. Okay? So it attacks from the backside and it is trying to make a new bond with the carbon. And in the same time, it is trying to push the leaving group away, push the halogen out of the system. Okay? So this is a very, very concerted system. This is a very concerted mechanism. Everyone is understanding what is happening. Nucleophile is attacking from the back and it is trying to make a new bond with the carbon, pushing the halogen out, pushing the halogen out. So what happens here, beta? So leaving group, it is trying to put it out, or I should just, you know, not directly just write it. I'll show you what happens in between. Check this out. So beta, what happens? One state would be achieved where carbon, check this out, this is very interesting. Acha, beta, everyone tell me what is the hybridization of this particular carbon or this alkyl halide? The hybridization is sp3. Do you guys agree? The hybridization is sp3. Yes or no? sp3 beta. In the alkyl halide, the hybridization is sp3. Do let me know everyone is understanding. Yes. समझ आता है, ये point बहुत important है. The hybridization was sp3. Absolutely perfect, right? Now here, the nucleophile is trying to make a new bond with the carbon and simultaneously it wants to push the halogen out, right? So it actually involves making and breaking of the bond. So that's why I'm saying this step is actually very concerted. This is a concerted reaction in which you will have simultaneous making and breaking of the bond. Okay? New bond is between nucleophile and the carbon, and the previous bond, the existing bond, CX bond, would be broken. Okay? So if you take a good look at it, beta, you'll have a partial positive charge. This is a highly unstable species. We call it as transition state. What do we call this? We call this as transition state. Highly unstable species, right? Highly unstable species. And right, so what happens here? This is actually, the carbon is pentavalent. आप देख सकते हो, carbon has 5 bonds. Impossible होता है, बहुत मुश्किल होता है. That's why I'm saying it is highly unstable. It will not stay like this. So what will be the next step, bachcho? I am pretty sure you guys are guessing it right. What will be the next step? What will be the next step? It will just convert. All of this is happening in one step. All of this is happening in one step. Okay? So what will be the next step? You will have a complete formation. You know, R nucleophile, hydrogen, and your leaving group is out. What has happened, beta? What has happened here? Check this out. Check this out. What has happened here? This is very interesting. Very, very interesting. The nucleophile has attacked from the backside and it has tried to make a new bond with the carbon and break the existing bond. And stronger the nucleophile, better it is. You guys remember polarization. In my classes, I have talked about this. If your nucleophile is strong, right, it will have a good polarization going on. If your nucleophile is strong, polarization would be more. So it can attack at this carbon and make a new bond and simultaneously it will push the halogen out. So stronger the nucleophile, better it is for you. It means SN2 requires strong nucleophile. Point number 1 I am going to talk about is that your SN2 reaction is governed by strong nucleophile because you want a bond to be formed and this particular bond will try to push or break the existing bond in a single step. So your nucleophile has to be strong. And in some books, if you will go ahead and read, it is also called as concerted step. This reaction is called very concerted, like it is a very concerted synthesis. Why is that? Because you get simultaneous making and breaking of the bond. This point is clear? Sabko samajh aaya? Is this point clear? Why it is called as a concerted reaction? It involves simultaneous breaking and making of the bond. Okay? And then it means SN2 reaction will be passing by a transition state, highly unstable situation. You will not be able to isolate it. You get a TS, a transition state in this formation where you see carbon is pentavalent. Carbon is pentavalent. बच्चा लोग एक बात बताओ, can you tell me what will be the hybridization of this carbon now? The hybridization here is sp2. sp3 था पहले, now it has become sp2. The carbon is sp2 hybridized and it is pentavalent. And can you tell me what is the shape here? What is the shape? You guys have learned coordination, this chemical bonding. What is the shape here? This is an unstable situation. What is the shape of this TS? Hybridization is sp2. I accept the point. Yes, hybridization is sp2. Let me write it with yeah, this is sp2. I hope you guys can see. Yes, it is sp2. I accept that. I agree with this. But what is the shape? What is the shape? Pentavalent, you know, this is trigonal bipyramidal. Trigonal bipyramidal. This is the shape. ये question आ जाता है. It's very very important. I hope the point is clear. ठीक है? I hope the point is clear. Here carbon is having a very unstable situation. It has having 5 bonds, pentavalent carbon. And what is the hybridization? sp2 is the hybridization. sp2 is the hybridization of the carbon. And beta, what is the shape? Pentagonal bipyramidal. Is this point clear? सबको समझ आया? ठीक है? Then what happens? It converts into nucleophile. It converts into, sorry, the nucleophile forms a bond and X minus goes out. Beta, if you notice, if this carbon, you know, if this carbon was chiral, check this out. Am I getting something which is completely reverse what we started with, completely invert of what we started with? Halogen was on the right side. Now your nucleophile is coming on the left side. This is called as inversion of configuration. Inversion of configuration. What has happened here? Your configuration got inverted. Okay? The configuration got inverted. If this would have been, if I started with a R compound, I might get now S. यहाँ पर S मिल जाएगा. ठीक है? What you are getting, not might, I'm pretty sure you will get S. Inversion, 100% inversion is obtained. What is happening here, beta? 100% inversion. देख सकते हो? The leaving group has left and the nucleophile has come from the back side. It has attacked from the back side. So have you gone out in a on a windy day? Have you gone out? And you have this umbrella in your hand because you are thinking that it might rain. It's windy, it might rain. I am taking my umbrella out, right? And suddenly it starts raining. It's very windy. It's raining very heavily. Have you noticed sometimes what happened? Your umbrella might just invert back, right? Might just do the inversion thing. Are you getting it? What I'm trying to say? Your umbrella would turn upside down. Yes or no? Yes or no? Correct? This is that kind of situation. This is inversion of configuration. The nucleophile will give inversion of configuration because it is attacking from the back side. It is attacking from the back side. Is this point clear? So in SN2 you get 100% inversion. I'll prove this. Actually, Walden was the guy who proved this. I'll show it to you today. Okay? Walden proved this, that in SN2 you get 100% inversion. Not even a single product will come where inversion would not be there. 100% inversion. Point is clear? Walden inversion. Absolutely correct. बिल्कुल सही, बिल्कुल सही. अच्छा. So I got this nucleophile is also ready. But I'll give one point today. In my mentee, I will discuss this. You see, on the TS, there is a partial negative charge. There is a partial negative charge. I would ask each and every one of you to remember this point. That TS has a partial negative charge on it. And I will discuss this point in my coming mentee quiz. Definitely, I'll use one question. I will give you one question on this. Okay? So please make a note of it that your transition state has a partial negative charge on it. Okay? Acha. So up to now, we have understood nucleophile is attacking from the back. I got an inversion product. Okay? Acha beta, now you tell me one more question I would like to ask you. One more question I would like to ask you. If my alkyl halide is bulky, attacking from the backside is difficult or easy? Answer it in the comment box. If my alkyl halide is bulky, nucleophile has to do a back attack. Nucleophile has to do a back attack. Would it be easy for the nucleophile to attack from the back and make a bond simultaneously? It will be difficult. It will be difficult because of the steric hindrance. Yes, it is difficult. Bilkul sahi Akshat. It is difficult because of the what? Steric hindrance. So which degree of alkyl halide is preferred in this experiment or in this SN2 reaction? If you want your rate to go up, SN2 rate you want to increase, right? If you want to increase the rate of SN2 reaction, which degree alkyl halide is best so that the nucleophile can attack? 123 or 321? Say it like this: 123 or 321? 123, I can't hear you. 123 or 321? Answer me. 123, absolutely. So 1 degree carbocation, 1 degree alkyl halide, I'm sorry, 2 degree, 3 degree, and one more thing I would like to tell. Best is methyl halide. Best one is methyl halide. Best one is methyl halide. Understood? So always remember 123. Here, if my alkyl halide is following the order of 123, the attack of the nucleophile from the backside would be easy. So that, I will get inversion of configuration. Okay? Awesome. Beta, I would also like to tell you, you are learning everything in one go. This entire reaction happened in one step. Sab kuch ek hi step mein hua. Everything happened in a single step. The rate of the reaction is dependent upon both the species. Let me highlight them. The rate of the reaction is, is dependent upon both the species, nucleophile as well as your alkyl halide. So the concentration, the rate of the reaction is governed by the concentration of the nucleophile as well as your alkyl halide. Is this point clear? Is this point? Yes, it is good, Beta Sheetal, it is good. Sabko samajh aaya? I hope everyone is understanding and enjoying the session so far. Sabko maza aaya? Sabko clear hua? Awesome. So now let me just give you a quick revision. So here inversion of configuration takes place, point number 1. Acha beta, check this out. The name is SN2 reaction. SN2 bimolecular nucleophilic substitution reaction. In the rate expression, boys and girls, what happens? The rate of the nucleophile as well as your alkyl halide is taken. Okay, that's why it is SN2 reaction. I hope you are getting the point now. I hope everyone got the point now. And let me just give this. So rate of the reaction is dependent upon the concentration of alkyl halide as well as your nucleophile. Here order is 2, molecularity is also 2. Rate is directly proportional to the concentration of the nucleophile and your alkyl halide. That's why SN2. And what is the ironic part, beta? How many steps it will take? How many steps it will take? Molecularity is also 2. How many steps it will take, beta, to finish the reaction? Ironic statement hai. This is ironic. Okay? Kind of a rhetorical question now. Good. How many steps it will take? 1 step. Awesome. Awesome, man. Awesome. Acha. I would like to inform one more point. I give you information about one more point. Many teachers skip that. काफी अच्छे teachers भी skip कर देते हैं. सोचते हैं बच्चा समझ जाएगा. बेटा एक बात बताओ. Tell me this. A very important step. But I said, let us imagine this alkyl halide is having the R configuration. So when you will do the attack of the nucleophile, strong nucleophile you have taken and you are attacking it, so you will end up getting inversion of product, right? Inversion of configuration will happen. And here, if you have taken R, you will get S, and vice versa. Some of you might start fighting with me, sir, why R? Vice versa, right? Vice versa as well. Okay? Now you tell me one thing. If I say this compound, this alkyl halide is dextrorotatory. Does it mean this will become LEVO? Does it mean, would it become LEVO? This is my question. If I started with a dextrorotatory compound, I get inversion of configuration. Would I get LEVO? Would I get LEVO? Would I get minus sign here? Anuj, yeah, you just blew my mind. Absolutely correct. Cannot say. This is an experimental phenomenon. We have to go in the lab and check. Okay? You will take the sample, go to the polarimeter, do that. Okay? It can be dextro, it can be LEVO. We can't comment on that. It is completely experimental. It is completely experimental. ठीक है? क्या समझ आया? Not always. Absolutely correct. ठीक है? सबको समझ आया? बिल्कुल क्लियर हुआ? It is completely experimental. Hanji. So you will say, I can't give my judgment here. I have a conjecture that, it can be LEVO, it can be dextro, it is experimental. Okay? You will say this. Amazing, amazing. Best organic chemistry book, NCERT. First thing I will prescribe, NCERT. LG Wade you can buy. ठीक है, अच्छी किताब है. I have studied from that. LG Wade, Solomon is also good. ठीक है? चलो, समझ आया? गुना बेटा जस्ट गो यार, मतलब काफी टाइम से बाय बाय कर रहा है. यू नॉट गोइंग. आई एम ऑफेंडेड नाउ. ऑलराइट, ठीक है, चलो इतना समझ आया, सब कुछ क्लियर हुआ. सो सी द की पॉइंट्स. न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन SN2 happens in one step. Rate of the reaction is dependent upon both the terms, two terms, nucleophile and alkyl halide. Order is 2, molecularity is 2, gives 100% inversion. I hope everyone understood this. ठीक है बेटा. In previous session, if you have attended my previous SN1 mechanism, I gave you a very, very important trick. I gave you a very, very important trick that one step means 1 TS. If a reaction has one step, it means it will pass through 1 TS. It will pass through 1 TS. ठीक है? अच्छा बेटा, एक और बात बताओ. I personally think SN2 is the easiest. Would this reaction have any kind of rearrangement? SN2 reaction में कोई rearrangement होगा? Do you think that SN2 reactions would have rearrangement in it? Do you think SN2 reactions would have rearrangement in it? What is the medium by which it is passing? It is passing by TS. It is passing by TS. Yes, Akshat. It is passing by TS. It does not pass by any carbocation intermediate like SN1 reaction. In SN1 reaction, you will have a carbocation intermediate which may rearrange. I have done a question just like that in the last lecture. Check that out if you haven't already. Okay? So there is a possibility you must be good in your carbocation. You should know carbocation rearrangement. Otherwise, you're gone. You can't do it. Here it is very easy. Remove halogen, put nucleophile on the opposite side. That's it, because the reaction passes by what? It passes by your favorite transition state. Understand? It does not have any kind of rearrangement. It's the most easiest for any student. All you have to do, just I will write it up here. All you have to do, if you have Rx, attack with your nucleophile. Nucleophile will attack from where? From the back. Halogen is tata bye bye, right? So now you end up getting this. समझ आया? You will always have a back attack because the reaction is passing via TS, transition state, and transition state has partial negative charge on it. I asked you to make a note of it because I'll give a question and teach you a point about that in the next session. Alright, बहुत सही. सबको समझ आ रहा है क्या? Is this point clear? Are you guys understanding, enjoying the session so far? Because I am enjoying a lot. ठीक है? I don't care what is the footfall here, whether it is my current video is having 25 students, 35 students or 4 lakh. 4 lakh तो ज़्यादा हो गया. 4,000 या 5,000, 5,000. I have taught 5,000 students live. ठीक है? Doesn't matter. I'm gonna give you my full energy. That's my promise. ठीक है? Alright, let's go ahead. So ये हमें समझ आ गया, सब कुछ clear हो गया. SN2 is clear. So this is your potential energy diagram. Boys and girls, this reaction passes via one step. One step means 1 TS. This is your TS. This is that situation. Let me just change the color of my pen, otherwise it will be a havoc for both of us. So here this is your TS na? Let me write the TS. This is your TS, boys and girls. Check this out. unstable situation, or I shall write here C. Correct? Guys, getting it? Are you guys getting it? समझ आया? Understand? Clear? This is your TS. One step, one TS. And TS is very, very high in energy. One TS, one peak. One more thing you can remember. One TS, it means in the curve, you will get one peak. Check it out. This is a reaction. You started with these reactants. You got this as your product. This is your transition state. In between, a TS was formed. Energy was highest. Then you got the product, which is having the least energy. Very easy, very simple. One TS, one peak. Remember this point, you will never go wrong in making potential energy diagram. This is actually a trick. This is a master trick. So you have got this from here. Amazing. Clear है बेटा? मजा आ रहा है? All right. Let's move ahead. आगे बढ़ते हैं. Now let us do a quick comparison between SN1 and SN2. In SN1 reaction beta, and let us write SN2 reaction. In SN1 reaction, rate of the reaction is independent over the concentration of your nucleophile. Let me write here. Let us say I have taken 1 and the rate was R. Let us assume if I am taking 2, what will be the rate here, beta? In SN1 reaction, the rate of the reaction is directly proportional to the concentration of alkyl halide only. If I say concentration here, I am doubling the concentration of alkyl halide. What will happen to the rate? And nucleophile I have also doubled. What will happen to the rate? Rate को क्या होगा बच्चा? Answer in the comment box. For 1 it was R. For 2 it will be what? Alia, जल्दी से बताओ बेटा, what will be the answer? I'm getting no response. This is kind of sad now. Now I got the answer. Very good. 2R. Absolutely correct. Absolutely correct. It will only depend upon the concentration of alkyl halide. If I say half, if I say 2, so you will say R by 2. Are you guys getting it? If I say 4, if I say 1, you will say 4R. Come over here for SN2 reaction. Here just now we have understood that rate is directly proportional to the concentration of alkyl halide as well as your nucleophile. Let me go out of your way. Check this out. So let us say 1 is R. So 2 will be equal to what? 4R, right? If I say half, this will become what? R. I hope everyone is understanding and enjoying the session so far. This is the difference. Someone asked me in the comment box, sir, how do you differentiate between SN1 and SN2? Beta, SN1 reaction requires weak nucleophile, like water, your favorite alcohol, okay? Weak nucleophile. And it happens in polar protic solvent like water, like alcohol. Actually, solvent itself acts as a nucleophile. That's the best part. If I give a reaction, I say water is there, Rx is there. You have to understand it is SN1. Okay? I can also use acetone in the presence of water. And that will also give you SN1 reaction only, etc. Come over here for SN2, your nucleophile beta. Your nucleophile is strong. जैसे SH minus, Cn minus, I minus, N3 minus, azide ion, right? N3 minus. You can have also, etc. More examples are there. RS minus, okay? Similarly, ETO minus, strong nucleophile, okay? RO minus, in general, RO minus. And it happens in the presence of polar aprotic solvent like DMSO or DMF, okay? सबको समझ आ गया? This is the best comparison I have just given you here, a best comparison. But bacha, one more question here. SN1, what are the general degree of alkyl halide that will give you the fastest reaction? If I want to speed up my rate, if I want to speed up my rate, what I should use? What order? 123 or 321? Moses, just wait 1 minute. Thomas, just wait 1 minute. 123 or 321? What should be the order of reaction, rate of the reaction? How can I pump up the rate of reaction in SN1? Which alkyl halide I should take? 123 or 321? Absolutely correct, my champions. You guys are following me. That means this 321. And for SN2, just now I have told you the rate 123. Right? If you are taking RX has to be of 123 order. Amazing. I'm so happy you guys are replying in a very nice manner. I'm liking it. Thank you so much. ठीक है, चलते हैं, आगे बढ़ते हैं. So now comes the movement, Walden inversion. Beta, Walden is the guy, and his name is Paul Walden. He did the experiment called as Walden's experiment. He proved that in SN2 you have 100% inversion. That the product will always have 100% inversion in it. Understand? Do you want to know how? Do you want to know how? Please let me know in the chat box. It should be flooded. Yes, sir. Please teach us why he, how did he prove that SN2 has 100% inversion of configuration? You have to be very, very, demanding for that. Then only I will explain. All right, ठीक है जी, चलो तो let's do this. मुझे तो मजा आ रहा है यार. I'm enjoying this particular class way too much. All right, so this is also done. So let's understand. अच्छा देखो, this guy was very, very smart. There was a limitation in polarimeter. Polarimeter is actually used to tell us the optical activity, whether the compound is optically active, or if it is optically active, what must be the specific rotation degree, whether it is dextro or levo. It tells us. Okay, polarimeter has one limitation. Polarimeter can distinguish H and deuterium. Achha, these are the isotopes. This is nothing but the isotopes. Isotope of hydrogen. Deuterium is the isotope of hydrogen, right? It can distinguish between hydrogen and deuterium. I repeat again, polarimeter can distinguish between hydrogen and deuterium. It considers them as two different elements. It considers them as two different elements, and it is okay. It can distinguish. For example, if I take this as a compound where there is hydrogen, there is deuterium, there is pH, there is some other group CH3. Beta, I would say this is a chiral center. This is a chiral compound. This is chiral. I would say that this is chiral. Everyone is understanding what I would say? This is chiral. Correct? It can distinguish, polarimeter would distinguish that there is hydrogen and deuterium. These are two different elements, and it will say it is chiral. Point number one. But there is a limitation. Limitation is what? It can't distinguish other isotopes. It can't distinguish other isotopes like chlorine, 35, 37. It can't distinguish them. It considers chlorine 35 and 37 as same. Iodine 127 and iodine 131. Achha, I would also like to report iodine 131 is radioactive. Understanding this point? Bromine 82, bromine 89. 80, 89 है यार, 80 है. Bromine 80 and 82. Bromine 80 and 82, not 89. ठीक है? Oxygen 16 and oxygen 18. They all are, these are isotopes, and the polarimeter cannot distinguish them. It cannot distinguish them. It considers them as same. Now Walden was very smart. He used this limitation to his advantage. ठीक है? He used this limitation to his advantage. Do you want to know how did he do it? Let us understand. So beta, what he did, check this out. He has taken a chiral compound where he has taken iodine 127, and he used NaI in the presence of acetone. This is a classical setup, and iodine, what he has taken, iodine is 131. Okay? Iodine here used is 131. The isotope of iodine that is used is 131, and this is a classical setup. This is a classical setup for SN2. Okay? This is a classical setup. NAI and acetone is a very good reagent for for SN2. Just now I told also. Okay? And I minus is a very good nucleophile, strong nucleophile. Okay? Achha, so this point is clear. Let me just erase everything. ये क्या हुआ? हाँ जी. Check this out. So here iodine 127 is taken and iodine 131 is taken in this case. SN2 reaction will happen. Everyone is understanding about this so much, so far so good. Everyone is understanding. So now iodine 131 will attack from the back. Acha beta, this compound was chiral to begin with. Let us say right now here the optical activity, let's say optical activity specific rotation is plus x. We don't know the value. Let's say it is dextrorotatory right now. It is plus x. Okay? Now what has happened according to polarimeter? Now what has happened? I131 will come and attack, but the polarimeter cannot distinguish. Okay? So what will happen? Back attack, iodine 131, hydrogen, Me, C6H30. Okay? Everyone is understanding? Acetone is a solvent beta. Acetone is a solvent. ठीक है? सबको clear हुआ? सबको clear हुआ? Everyone is understanding? And side by side beta, you will also get I127. मेरे को एक बात बताओ. This is also current. Beta, now according to polarimeter, the specific rotation will change. Let us say it is coming as minus x. How much it is coming? Minus x. ठीक है? मैं एक बार repeat करता हूँ प्रियांशु. No, it is not necessary. We have just taken radioactive isotopes. It can help us in such things, right? So we can easily date. Basically, I have taken 127 and 131. 131 has radioactive nature. That's it. ठीक है? उससे घबराओ मत. That is not a very important feature here. The important part is that polarimeter considers iodine 127 and 131 as same. Okay? It cannot distinguish them. So according to the polarimeter, first in the reactant side, specific rotation was plus x. Then I131 will attack and replace 127 from the back side. Okay? This particular product now would be having specific rotation as minus x. Are you getting this point? Acha, beta, now pay attention to this point. Pay attention to this point. Okay, why? Now let us understand this reaction is not over. Now what will happen? This I127 will not sit idle. Okay? It will also start attacking back. Now it will start attacking back and it will give you a back reaction. It will give you a back reaction. सबको समझ आ रहा है? It will give you a back reaction. ठीक है? ये advanced का point है. The point which I am discussing is coming from JEE advanced point of view. I'll give you a question as a homework which you will think about. ठीक है? And in the next session we will discuss it vividly. ठीक है? अच्छा. Now check this out. Check this out. So this I127 will also have which kind of attack? We are speculating it should be also an SN2 attack. Now, beta, imagine this reaction will start going backwards. So there will be an equilibrium. One point will come, that equilibrium would be established. Do you guys agree? One point will come and equilibrium will be established. One time it is having plus x as optical activity, specific rotation, and specific rotation next time is minus x. Okay? And this is happening all the time. One point will come where you will have equilibrium. Beta, at equilibrium, I'm asking you, at equilibrium, according to you, what must be the optical activity? What must be the, this one, rotation, specific rotation? What must be the optical activity or the specific rotation? What do you think? Then I will explain. Jaldi batao. I'm waiting. Very interesting. Sheetal, you just are amazing. Very nice. Bilkul sahi. At equilibrium, he concluded this, and see, very, very important thing. He found that the specific rotation was 0. It means it is optically inactive. There is racemization happening. There is a racemic mixture at equilibrium. There is a racemic mixture at equilibrium. And you understand what you have just told me is so mind-blowing. Imagine the, try to imagine the gravity of what you just understood. He predicted that it should be 0. And the experiment also said it is 0. Then he gauged, he carefully said this one point, that this is my conclusion. This is my conclusion. That see, this attack is always 100% inversion product would be from this attack. You will always get 100% inversion. By chance, if there would have been any front attack, the specific rotation would not be 0. It would have been some value, let us say 1, no matter how small, but there would be some value in the specific rotation, right? Right now it is 0. It means that always the attack is happening from the back side. Are you guys getting it? Since the polarimeter is not able to distinguish between I-127 and 131, it considers them as same. So one time it is giving you first in the product side, reactant side, it was giving you plus X as the specific rotation. In the product side, minus X. Equilibrium came, nothing was there. Are you guys getting it? You just understood something really, really special. Really, really special you have just understood. So from this experiment, he concluded, yeah, it is 100%, it is 100% inversion product. Dekho, I can go in much more detail, but I want you to think about it because I will give you a JEE advanced problem. JEE advanced problem was, if the rate of the reaction, do you want me to give you the exact detail, or do you want one more session on it where we can discuss this JEE advanced problem? Do you want to use your brain, or you just want spoon feeding? What do you want? You decide. I can give you the right answer, Abhi. I can give you one more extra step that will help you understand much better. But I want you to struggle. Struggle is real. I want you to struggle so that you can actually come up with a better answer. No, Sheetal, no need to study more about polarimeter. Whatever the information is given is enough. All right. The question is, the rate of reaction was X. Let us say it is R1, not X. Let's call it as R1. Let's call it as R1. Then there is also racemization happening. Rate of racemization, let us call it as R2. What is the relationship between R1 and R2? That is the question. What is the relationship between R1 and R2? Question is clear. This question came in JEE Advanced based on this polarimeter, based on this Walden experiment. Walden inversion got Nobel Prize for that. Did I tell you that? This experiment got Nobel Prize. You want to try, Jeremy? Do I conduct, I will make one more session on this. We will just discuss. That will be a 10-15 minute session. Let it be. But I want my students to think about it. What do you say? Priyanshu Rai is giving answer. Thank you for trying, but wrong answer. Jay Krishan, wrong answer. Thank you for trying anyway. Or, batao. I'm just waiting. Okay. So let's have one more session on this. The answer is pending, right? The solution. You can give it in the comment box. And if you have loved the session today, अगर आपको बहुत अच्छा लगा है, if you love the session today, if you love the session today, you could let me know in the chat box as well. Okay? Because I tried to do something different today. I did not try to give you spoon feeding. I did not do spoon feeding today, sorry. I am trying something new. Okay? So let's do that. Let's visit this question again. If you get your answer, let me know in the comment box also. I will also answer there. Okay, so that's it from my side. Thank you so much. It was a pleasure. If you love this session, please like the video. Also subscribe to our channel. And thank you so much. Thank you so much, boys and girls. This is it for today. See you next time. This is your captain. Much love.